All right, we are going to continue our lesson from yesterday, factoring trinomials, going from standard form to factored form. The only difference today is our coefficients to our quadratic term will not be 1. So the process will be the same, but it will be a tad bit different. So let's just dive in. All right, I have standard form 2x squared plus 9x plus 4, and I need to identify my a, b, and c value. So my a value is the coefficient of my quadratic term, my b value is the coefficient of my linear term, and my c value is my constant, the number that doesn't have a letter. So that would make my a value be 2, my b value be a positive 9, and my c value be a positive 4. I'm going to partially complete my area model, putting my quadratic term in the upper right-hand corner first, which is 2x squared, and my constant term in the bottom corner, which would be 4. All right, I want to rewrite my linear term, aka my b term, with two numbers that multiply to a times c and add to b. So what is my a value? 2 times my b value of 4, which gives me a times c, which is equal to 8. So I want two numbers that are going to multiply to 8, but add up to my b term, which is a positive 9. So I go to my factor pair list, and I find factors of 8. Because I want the two numbers to multiply to positive 8. So numbers that multiply to positive 8 are 1 times 8 and 2 times 4. Either way, they're going to multiply to a positive 8, but I want them to add to a positive 9. So what is 1 plus 8? 1 plus 8 is equal to 9, and 2 plus 4 is equal to 8. That means that I can use these two numbers, 2 and 4, just kidding, 1 and 8, because those numbers add up to 9. So I'm going to rewrite my b term as a 1x and an 8x, because 1 plus 8 will give me 9. All right, now I need to find my factors, aka the greatest common factor between each column and each row. Now I'm going to start with my purple box because I see this x squared here, which is going to tell me on each side of this box I should have an x. We just have to figure out the coefficients if there should be any. So let's look at our first column. I want to know what is the greatest common factor between 2 and 8. So I go to my factor pair list, and I find the factors for 2 and the factors for 8. So when I look at these highlighted factors of 2 and 8, 1 times 2 gives me 2, 1 times 8 gives me 8, 2 times 4 gives me 8. What's the biggest number that this 2 and this 8 have in common? Hopefully you said a 2. That means on the outside of this box, the greatest common factor for 2x squared and 8x would be 2x. Okay, now let's look at this row, because it really doesn't matter what order we go in, but we can look at this row. I can ask myself two things. What can I multiply 2x by that will give me 2x squared? Or what's the greatest common factor between 2 and 1? So I can go to my factor pair list, find factors of 1, find factors of 2. What's the biggest number that they have in common? 1. So on the outside of this row, the greatest common factor between 2x squared and 1x will simply be 1x. Because 1x times 2x gives me 2x squared. 1 times 2, 2, and x and an x squared. All right, let's look at this column. what can I multiply? I need a number to go right here. What can I multiply 1x by to give me 1? It's the same. So just positive 1. All right, but what about this row? I can ask myself 2 questions. What can I multiply 2x by that will give me 8x? Or what is the greatest common factor between these two numbers, 8 and 4? So if you like the factor pair list, we can look at the factor pair list. And I can find factors of 4, and I can find factors of 8. What is the biggest number that the factors of 4 and the factors of 8 have in common? So you probably say, oh, Miss Carter, both of them have a 1. True. Both of them have a 2. True. Both of them have a 4. True. What's the biggest number? 4. So that means the greatest common factor between 8 and 4 will be a positive 4. Because 2 times 4 will give me 8. So I have my factored form. My factored form would be the terms on the top, which will be 2x plus 1. And the terms on the side, which would be x plus 4. So now it's time to find our zeros using our zero product property, which means one of my factors would be 2x plus 1, and the other factor would be x plus 4. So let's solve for the orange one. All right, 2x plus 1 is equal to 0. How do we solve for x? I can subtract 1 from both sides, which will cancel out my 1's, and I can bring down my 2x. And what is 0 minus 1? Negative 1. But my x value is still not isolated because it's being multiplied to 2. So what is the opposite of multiplying by 2? Dividing by 2. What's going to cancel out? And then I have my 0 of x is equal to negative 1 over 2. But I also have to solve for my pink one. So x plus 4 is equal to 0. How do I solve for x? Subtract 4 from both sides. What is going to cancel out because they're opposites, which will leave me with x is equal to, what is 0 minus 4? Negative 4. So my two solutions should be x is equal to negative 1/2 and x is equal to negative 4. So we're going to go to our Desmos graphing calculator to check our answers. So my original standard form was 2x squared plus 9x plus 4. And the factored form that we got was 2x plus 1 times x plus 4. And they match, which means it's right. So let's check our zeros to make sure that they are correct, because my zeros are telling me that it should cross the graph at x is equal to negative 4, and it does, and x is equal to negative 1 over 2. Well, they have negative 0.5. So if you are not sure how to convert your fractions to decimals, we can use Desmos. I can type in negative 1 over 2 and see if it is equivalent to negative 0.5, and it is. So we did it correct. All right, let's look at our second example. The standard form that they gave me this time was 4m squared plus 8m minus 5, and I need to identify A, B, and C. So my A value, the number in front of my quadratic, my B value, the coefficient in front of my linear, and my constant, the number by itself that does not have a variable. So that will make my A value 4, my B value a positive 8, and my C value a negative 5. I'm going to go ahead and partially complete my area model, putting which term in my first corner? The quadratic one, which is 4m squared. Which term would I put at the bottom corner? My constant term, which is a negative 5. Now I need to rewrite this linear term into two values that multiply to A times C and add to B. So if I multiply my A times C, that means I'm multiplying 4 times a negative 5. 4 times negative 5 will give me a negative 20. So A times C is equal to negative 20. So I want two numbers that multiply to negative 20, but add to a positive 8. So I need to go to my factor pair list. And on my factor pair list, I'm going to find factors of 20. All right, but I want my product to be a negative. Well, two positives make a positive, so that means I cannot use that combination of values. Well, two negatives give me a positive, so I can't use that combination of values. But a positive times a negative is a negative, and a negative times a positive is a negative. So that's how we will rearrange our values. So to get a product of negative 20, I can multiply a positive 1 times a negative 20 or a negative 1 times a positive 20. I can multiply a positive 2 times a negative 10 or a negative 2 times a positive 10. I can multiply a positive 4 times a negative 5 or a negative 4 times a positive 5. These are all of the combinations that will give me a product of negative 20. But I want them to add to a positive 8. So if I struggle with integers, I'm going to use my handy dandy calculator. 1 plus negative 20 is equivalent to a negative 19, which means I don't want to use that. I can't use those two numbers. A negative 1 plus 20 gives me a positive 19. I want it to be a positive 8. 2 plus a negative 10 gives me a negative 8. I want it to be a positive 8. So I can't use these two numbers. A negative 2 plus a positive 10 gives me a positive 8. I have found my combination of numbers. These are the two numbers that I want to rewrite my B term as. So in my little green hearts in the corner, I'm going to write a negative 2m and a positive 10m because 10 minus 2 is 8. All right, now it's time to find our factors, aka our greatest common factors. I'm going to erase this so we can have a little room. All right, so let's look at our first box because it always seems to be the easiest. What two letters can I put right here that will give me this m squared? Hopefully you said an m and an m. But now we got to look at this 4. So we can look at the row or the column. So let's look at the column. 4m squared and 10m. We have already taken care of the variables, so all we're looking at is numbers right now. I need factors of 4 and 10 so I can see which one is the greatest common factor. So I go to my factor pair list, and I am looking for factors for 4 and factors of 10. And I want to know what's the biggest number that they have in common. Both of them have a 1. Is it the biggest though? No. So 2 would be the greatest common factor between 4 and 10. So that means on the outside of this column, I can put a 2. Well, what about this row? What would be the greatest common factor between 4 and negative 2? So I find my factors of 4 and my factors of 2. What is the biggest number that they have in common? A 2. So that means on the outside of this row, I can put a 2. And then we're going to check 2m times 2m, 2 times 2, 4, m times m squared. Okay. Now, let's look at this row. I can do it 2 ways. 2 times what will give me 10? So 10 divided by 2 is 5. That means that 2 times 5 is 10. Because 2m times 5 gives me 2m. All right. Then I ask myself the same. I want to fill in this spot. What can I multiply by 2m that will give me negative 2m? Well, negative 2, boom, divided by this 2, boom, gives me negative 1. That means that I can multiply by 2m, I can multiply a negative 1, and that will give me negative 2m. Now, just double check. 2m times 2m, yes. 2 times negative 1, yes. 5 times 2m, yes. 5 times negative 1, yes. I have my 2 factors. The one going across, which is 2m minus 1. And the one going down, which is 2m plus 5. All right, let's look at example number 3. We have 6g squared minus 13g plus 6. And I need to identify a, b, and c. My a value in front of my quadratic term, my b value, the coefficient of my linear term, and my c value, my constant. So my a is 6, b is negative 13, and my c is positive 6. I'm going to go ahead and partially complete my area model, putting which term in the first upper corner, your quadratic, which is 6g squared, and which term in the bottom corner, your constant, which is a positive 6. To rewrite my b term as 2 terms, I must first find 2 numbers that multiply to a times c and add to my b term. So a is 6 times c, 6 times 6 gives me 36. So I want 2 numbers that multiply to 36 but add to a negative 13. All right, so we go to our factor pair list and we find 36, which is right here. All right, I want my 2 numbers to multiply to a positive 36 but add to a negative 13, which means I will have positive and negative numbers. So these are the combinations that I can use because I want it to give me a product of a positive value. So to get a product of a positive 36, I can multiply a positive 1 times 36 or a negative 1 times a negative 36. Either way, I get a positive because a positive times a positive, positive, a negative times a negative, positive. Okay, I can also multiply a positive 2 times 18 or a negative 2 times a negative 18. 3 times 12 or a negative 3 times a negative 12. 4 times 9 or a negative 4 times a negative 9. And 6 times 6 or a negative 6 times a negative 6. All of these will give me a product of a positive 36. But I want my 2 numbers to add to negative 13. So if I add 1 plus 36, what do I get? I get a positive 37. Well, I can't use those because I want it to be a negative 13. What about a 2 plus a 18? Well, that gives me 20. I want it to be a negative 13 because negative 2 plus a negative 18 gives me a negative 20. So go down the list and find the numbers that will add up to a negative 13. And hopefully you chose a negative 4 plus a negative 9. Because those add up to a negative 13. That means the two numbers that I want to use to rewrite my B term would be negative 4 and negative 9. So I will have a negative 4G and a negative 9G because negative 9 plus a negative 4 gives negative 13. Now it's time to find our factors by finding the greatest common factor of each row and each column. Let's start with the purple box because it has 6G squared, which means how many G's will I have on each side? 1. All right, we just need to find the numbers now. We got the letters and the letters are out of the way. So to find the greatest common factor of this column between 6 and 9, I need to go to my factor pair list, find the factors for 6, find the factors for 9, and see which one is the biggest. And the biggest number that 6 and 9 have in common is a 3. So the number outside of this column should be a 3. Well, what about the number outside of this row? What is the greatest common factor between 6 and 4? So I go to my list, I find factors of 6, I find factors of 4. What is the biggest number that they have in common? A 2. So that means on the outside of this row, the greatest common factor between 6 and negative 4 would be a positive 2. Why is it positive? Because 2 times 3 is a positive 6. Now I can use these two to help me find these. What can I multiply by 2 that will give me negative 4? Well, negative 4 divided by 2 is a negative 2. Therefore, 2 times negative 2 is negative 4. I can multiply negative 2 by 2 to get negative 4. Well, what about outside of this row? What can I multiply 3 by to give me a negative 9? Negative 9 divided by 3 gives me a negative 3. So 3 times negative 3 is negative 9. Negative 3 times negative 2 is a positive 6. I have found my factors. One of my binomials going across the top would be 3G minus 2. And the other factor going down would be 2G minus 3. All right, let's look at our last example for today. They gave me the standard form 6x squared minus x minus 15. And I must identify A, B, and C. A in front of my quadratic term, B in front of my linear term, and C in my constant that it does not have a variable. So my A term would be a positive 6. My B term would be a negative 1. Remember, it's invisible, but it's a negative in front of the x, which means it's a negative 1. And my constant term, a negative 15. All right. So I'm going to go ahead and partially fill in my area model with what two terms? Your quadratic term in the up first corner and then your constant in that bottom corner. And I have to rewrite my linear term, aka this negative 1, into two numbers. All right. I want these two numbers to multiply to my A times C value. In this case, 6 times a negative 15. So 6 times a negative 15 gives me a negative 90. So I want my two numbers to multiply to a negative 90, but I want it to add to my B term, which is a -1. So let's put up our factor pair sheet, and we're going to find 90, which is all the way over here. All right, so we have our factor pairs of 90, all of these, everything in this box. But I want them to multiply to a -90. That means if I want my product to be a negative, equal to a negative number, one of my values would have to be positive and the other value would have to be negative. All right, so I can do a +1 times a -90 or a -1 times a +90. Either way, they're going to multiply to -90. I can do 2 times a -45 or a -2 times a +45. I can do 3 times a -30 or a -3 times a +30. I can do 5 times a -18 or a -5 times a +18. I can do a 6 times a -15 or a -6 times a +15. Or I can do a 9 times a -10 or a -9 times a +10. These are all of the combinations in the world that will multiply to a -90. But I want them to add to a -1. Well, 1 plus -90 is -89, therefore that ain't it. And a -1 plus a +90, if I could type it in right, gives me an 89. So go down the list and find the two numbers that's going to add up to a -1. And so you should have come up with a 9 plus a -10, because 9 plus a -10 is going to equal to a -1, which means the two numbers that I want to use are 9 and -10. So I'm going to take 9 and -10 and rewrite my B term as a 9x and a -10x, because -10 plus 9 gives me -1. All right, now it's time to find our greatest common factor from each row and each column. So let's look at this box. It's the easiest one to work with so far because we already know what two letters are going to go on the outside of this box if it gives me an x squared on the inside. We just have to find the coefficients. So let's look at this box. We're finding the greatest common factor between 6 and 10. So I'm going to write them over here in the corner. I'll pull up my factor pair sheet, and I'm going to go to 6 and 10. So here are my factors for 6, and here are my factors for 10. What is the biggest number that 6 and 10 have in common? It would be a 2. So that means the greatest common factor for this column would be a 2x. Okay, we can work this a lot of different ways. If this is a 6x squared on the inside, and this is a 2x on the outside, what can I multiply to 2 to give me 6? So 6 divided by 2, 3. Because 3 times 2 is 6. So we can take these and work our way around the box. 9x, I can look at it two ways. I can say, question 1, what can I multiply by 3x that is going to give me 9x? Or I can say, what is the greatest common factor between 9 and 15? So if I want to go that route, I would find my factors of 9 and my factors of 15 and say, what's the biggest number that they have in common? And hopefully you would have said a 3. Which means I can get a +3 here. And that is right, because 3 times 3 gives me 9. So for the outside of this box, I can do it one of two ways. What can I multiply by 2 that is going to give me -10? Or what's the greatest common factor between negative 10 and negative 15? So go to my factor pair sheet. There go, I already have my factors of 15. Here go my factors of 10. What's the biggest number that 10 and 15 have in common? Hopefully you said a 5. But since this is a negative, that means it will be a negative 5. Because 2 times negative 5 is negative 10. Negative 10 divided by 2 is negative 5. So my two factors would be 2x plus 3 and 3x minus 5.